Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Tutorial. Part 6. In this video we will discuss about all these 16 things. So let's get started without further delay. Alright, first we will discuss about I/O with numpy. So, numpy offers utilities to read and write data from and to files, which can be particularly useful when dealing with numerical data. The two main functions for file I/O in numpy are load text and save text. Let's explore these functions in detail with examples. Let's see here, load text is used to load data from a text file. It is versatile and can handle various types of data files. And these are the syntax. Let's see here we have a text file called data.txt. And here we have numeric data from 1 to 9 as you can see. Now we reading the file using numpy load text. Let's see here we got data from that text file. Now we will know about numpy save text function. The save text function is used to save an array to a text file. And this is the syntax. So first we will create an array. So, these are the code to save an array to a text file. Now you can see here, we don't have any text file, namely data_out.txt. Now see here, the file data_out.txt has been successfully saved. Alright, as you can see here we got a new text file called data_out.txt. And these are the data came from array. Now we will load this file again, which was we saved just now. Now see here we mentioned data type float, and skip header equals 1 means this line. And skip footer means this line. So let's execute it. As you can see here we got the data from our new text file. These are the basic functionalities for file I/O in NumPy. They allow you to easily read and write numerical data from and to text files, which is essential for data analysis and scientific computing tasks. Now we will dealing with comma separate value files in short CSV file. Now we will calculate the volume weighted average prices. In short VWAP. Volume weighted average price is a very important quantity in finance. It represents an average price for a financial asset. The higher the volume, the more significant a price move typically is. VWAP is often used in algorithmic trading and is calculated using volume values as weights. Now we will show you our directory. So you can see here we have a stock CSV file. This file contains stock related data. As you can see here. And here we have total 249 rows. If we will minus first row as row header from 249, then we will get 248, which is actual data rows. And one thing I would like to say here, if anyone who needed this file, then you can tell me on comment section below. Now see here we used column 5 and 7. See here column 5 is close price and column 7 is volume. Basically here are two common approaches to calculate VWAP in NumPy. Method 1, using NumPy average with weights. This method directly uses the NumPy average function with the weights parameter set to the volume array. This calculates the weighted average of prices based on the corresponding volume. Let's see here we got this value. Let's explain the method 1. Let's see here, this method calculates the single average price weighted by the volume for all 248 rows of data. It essentially treats the entire dataset as one entity and computes the weighted average across all prices and volume. Therefore, it gives you one output value representing the overall VWAP for the entire dataset. So method 1 gives you the overall VWAP for the entire dataset. So now we will know about method 2. Method 2, using cumulative sums, this method calculates the cumulative sum of volume and price multiplied by volume. Then, it calculates VWAP by dividing the cumulative price volume by the cumulative volume. Let's see the example. Let's see here, we got 248 volume weighted average price. As you can see here, that means here we got VWAP for each row in the data set. Let's explain the method too. This method calculates the VWAP for each row in the data set. It iteratively accumulates the price multiplied by volume and volume for each row and then divides them to get the row-wise VWAP. Therefore, it provides you with 248 output values, one for each row in your data. So method 2 gives you the individual VWAP for each volume in your data set. So which method to choose, it depends on your specific needs. If you need the single average price representing the overall trend in your data, use method 1. If you need the VWAP for each individual, use method 2. So now we will discuss about numpy mean function. The numpy mean function computes the arithmetic mean, average, of the elements along the specified axis. It takes the following syntax. Here you can see, here we used close price data. Now here you can see the output. And note down this. Now we will calculate the average close price manually. Now you can see we got the same output from both functions. So I hope, now you understand the difference between mean and average. Now we will discuss about time-weighted average price. Time-weighted average price, in short TWAP, is a trading algorithm used in finance to execute a large order over a specified time period in order to minimize market impact. It calculates the average price of a security over a specified time frame, with each data point weighted equally. Now we will see example 1. Now you can see here we got time-weighted average price. In this example, suppose we want to compute the TWAP of a security over the given time intervals. The price data and time intervals might represent the price of the security and the time elapsed since the start of trading, respectively. By multiplying each price by its corresponding time interval, we give more weight to prices observed during longer intervals, thus reflecting a time-weighted average. Now we will see another example with CSV data. As you can see here we use two type of method to calculate TWAP. So let's execute it. As you can see here, we got both result are same. Alright, now we will discuss about numpy median function. The numpy median function in Python's numpy library is used to compute the median along a specified axis. The median is the middle value of a sorted dataset. If the dataset has an odd number of elements, the median is the middle value. If the dataset has an even number of elements, the median is the average of the two middle values. Let's explore this. Now see here we got a median value from closes price. So we note down that. Now we trying to access the median value from closes price manually. Now here we find the median value inside the sorted closes price. Now see here we couldn't find 209.90, so now we copying these two middle value. Now see here this is the middle value. Now see here, if the data set has an even number of elements, the median is the average of the two middle values. Now you can see here. Finally we got the median value. So this was the median function. Now we will discuss about another statistical measure. Another statistical measure that we are concerned with is variance. Variance is a measure of the spread or dispersion of a set of data points. It's particularly useful in statistics for understanding the variability or volatility of a data set. Let's see the example. As you can see here we got the variance. Let's double check using the definition of variance. As you can see here, we got same output from both of these. Now we will discuss about numpy diff function. The numpy diff function computes the difference between adjacent elements of an array. It calculates the discrete difference of elements along a specified axis of the array. This function is particularly useful in time series analysis, signal processing, and numerical differentiation, and this is the syntax. Now see here, here we got 2, 3, 4, 5. Now we will know why we got it. See here, 3 minus 1 equals 2. 6 minus 3 equals 3. 10 minus 6 equals 4. And 15 minus 10 equals 5. So this is the one-dimensional array difference. Now we will see another example. Now see here, here we got 2D array difference along axis 0. Let's explore the 2D array difference. See here, this is the first row. And this is the second row. And now see the difference. See here, 2 minus 1 equals 1. 5 minus 3 equals 2. 9 minus 6 equals 3. And rest of the elements are calculated in same process. Now we will see another example 2D array along axis 1. Let's see the output. As you can see here, here we got two-dimensional output. Let's see here, 3 minus 1 equals 2. 6 minus 3 equals 3. 10 minus 6 equals 4. And rest of the elements are calculated by same process. Now we will see another example with specifying n parameter. Let's execute it. Here we got 111 as you can see. Let's explore this. See here, this is the original array. And this is the first difference. And this is the second difference. So that's why we got 111 as output. Now we will see another example with prepend and append. Let's see the output. Let's explore this. So this is the original array. And this is the prepend. And this is the append. Now computing the difference. So 1 minus 0 equals 1. And rest of the elements are calculated by same process. So this was the numpy difference function. Now we will dealing with dates in numpy. We already have a stock data with CSV file. So first we will read the close price data. Second, we will split the prices according to the day of the week. Third, for each weekday, we will calculate the average price. Finally, we will find out which day of the week has the highest average and which has the lowest average. Now we importing the date time. Now we will define a function to convert date string to weekday float. That means Monday equals 0, Tuesday equals 1, Wednesday equals 2, like this. Now you can see here we got floating point instead of weekdays, which is representing each day of week. Now we will execute it. Now see here, top day of the week is 3, which means Thursday, and this is the lowest average price. And lowest day of the week is 2, which means Wednesday. Now see here, day 3 prices start from here. Now see here, this is the highest average price. And this is the lowest average price. Now we will summarizing the data for entire business week running from Monday to Friday. As you can see here we using these 5 columns. Now we will select first 16 elements from the closing prices. Now we will select first 16 elements from the dates. As you can see here, the first Monday index is 4. And the last Friday index is 12. Now see here, the first Monday index is 4. And see here Monday is 0. So now here we counting the index from 0 to 4. As you can see here we got 0 at index 4. And similarly last Friday we will find in index 12. Now see here weeks indices initial from 4 to 12. And after splitting the indices array, the array is divided into 3 equal part. As you can see here. This function summary takes a set of indices corresponding to a week and outputs the summary information for that week, such as Monday's opening price, week's highest price, week's lowest price, Friday's closing price. And now we will save the summary data into a CSV file. Let's execute it. Now you can see the week summary. And after saving here we got week summary CSV file. Now we will discuss about the average true range, in short ATR. The average true range is a technical analysis indicator that measures market volatility by calculating the average range between the high and low prices over a specified period. So this is the formula of ATR calculation. Now you can see here we extracted the high, low, and closes price data from CSV file. Let's execute once. Actually here we want to show you, how does roll function work. These are the high price. And these are the closes price. And here we applied the roll function. This function shifted elements beyond the last position are reintroduced at the beginning of the array, and vice versa. Now see here this last element shifted to first position. Now see here we got this output, that means this is the average range between the high and low prices overall. Now we will calculate this iteratively. Now you can see here we got ATR value for each day. Now we will computing the simple moving average like this. So first we will import the matplotlib library. If you have not installed this library on your machine, just type here this and press enter. So here we have already installed, so we delete this. Here we using only column 5, that means closes price. Now you can see here, this is the 5 days moving average. This is the days. And this is the prices. See here, this dashed line is moving average. And this blue line is original data. Now we will calculating the exponential moving average. So let's execute it. Now you can see here, blue line is original data, and green line is exponential moving average. Now we will know about enveloping with Bollinger Bands. Alright, now you can see here, this band is denoting the main data. This orange band is denoting the moving average. And this is the upper band. And this is the lower band. And this is the highlight points between the bands. Now we will change the bandwidth. So this was Bollinger Bands. Now we will discuss about predicting price with a linear model. Now you can see the matrix with 5 rows and 5 columns. Now you can see the output. This is the coefficients x. Residuals is nothing. This is the singular values of a. This is the dot product of b and x. So this was the linear model. Now we will know about how to drawing trend lines. So here we use column 3, 4, 5 from stock CSV, which is representing the high, low, and close prices. So now our program is ready to execute. Now see here, this is the close price band. And this is the support line. And this is the resistance line. And this is the point between the lines, which is 0, so it doesn't show up here. Now see here, number of points between support and resistance bands is 0. Ratio of points between support and resistance bands to total close prices is 0.0. And predicted support for the next day, and predicted resistance for the next day are these. So this was the trend lines. So our today's video was up to this. Thanks for watching the video. See you in the next video. Please subscribe our channel. And don't forget to like the video. Thank you.